Hello everyone, welcome to Math 7. So we have a question shared by one of my students. And this is the question. 7 minus 4 root 3 divided by 7 plus 4 root 3 equal to a minus b root 3. So we are asked to find out the value of a and b, right? So how do we solve this? Actually, I'm very happy to have received this question. So thank you, Aaron, for sending this. And I request all my students to keep on sending more and more questions so that I can keep on solving your problems and finding your solutions, right? So let's see how we solve this. When you have such a problem where you have square root of something in the denominator, right? We don't actually need square roots in the denominator. It's always better to see square roots in the numerator, but we don't want square roots in the denominator. So the first thing is, our main intention is to make sure that we somehow eliminate the square root from the denominator. So that's our main aim. Let's see how we do this. So the LHS of this equation, taking this, we can write this as, what I do is 7 minus 4 root 3, right? Divided by 7 plus 4 root 3. And we see that in the denominator we have 7 plus 4 root 3. Let's take the conjugate of that. Okay, so 7 plus 4 root 3 means its conjugate is 7 minus 4 root 3. And we all know that a plus b into a minus b will give you a square minus b square. So this is an important identity that you need to keep in mind whenever you have such problems involving a root, square root in the denominator. So when you use this identity properly in the denominator, it will help you get rid of the square root in the denominator. So what you have right now in the denominator is something like a plus b. Alright, so if you multiply that by a minus b, you end up getting a square minus b square. And when you square the square root, obviously the square root disappears, right? That's exactly what we want. So we want a whole number. We want to get rid of the square root and we want a whole number in the denominator, right? That's our aim. Now, if I do the same thing here, just as I said, I am taking the conjugate of this particular denominator, which is 7 minus 4 root 3, and I am multiplying that both to the numerator and to the denominator. So I am multiplying 7 minus 4 root 3 in the numerator and also in the denominator. So that means this is making no effect to the answer, right? So I'm multiplying the same thing in the numerator and the denominator. Obviously it gets cancelled. But what we get is that somehow we managed to get rid of the square root in the denominator. Now what happens? Let's see. We see that in the numerator, this becomes 7 minus 4 root 3 the whole square because it is multiplied 2 times, correct? So this is 7 minus 4 root 3 the whole square divided by, and what happens in the denominator? This is a plus b into a minus b, right? It is a square minus b square. So this becomes a is 7 and b is 4 root 3. What is a square? What is 7 square? It is 49. And what is 4 root 3 the whole square? It is 4 square into root 3 square. 4 square is 16 and root 3 square is 3. So 16 into 3 means 48, right? So in the denominator now we have 49 minus 48, which is 1. We don't have a square root anymore, right? Now what happens when I expand the numerator? This is nothing but a minus b the whole square, right? What is a minus b the whole square? It is a square minus 2ab plus b square. A square is 7 square, which is 49, right? Minus 2 into 7 into 4 root 3. 2 into 7 is 14. 14 into 4 is 56. So we get 56 root 3 plus b square, that is 4 square into root 3 square, which we already got. It is 48, correct? So this is what we get in the numerator, and the denominator is obviously 1. So what we got is What is 49 plus 48? Let's take the add the whole numbers first. 49 plus 48 is 97, right? So we have 97 minus 56 root 3. Now let's go back to the question and have a very clear observation of what is given on the right hand side. It is a minus b root 3. So somehow we have managed to simplify the left hand side and we got the answer as 97 minus 56 root 3. But it is given that this is equal to a minus b root 3. Now we see that we have a constant a here, we have a constant 97 here. So let's rewrite that. So what we got is a minus b root 3 is equal to 97 minus 56 root 3, right? Now, watch carefully, observe carefully. A is a constant, 97 is a constant. B root 3, 56 root 3, minus here, minus here. So just compare the like terms. Here the like terms are A and 97, they are independent numbers, constants. So we can say that A will be equal to 97 minus minus, both are same. B root 3, 56 root 3. So root 3 is common to them. That means the coefficient of root 3 has to be equal to B, as simple as that. So we get B is equal to 56 and that's it. So we have found out A equal to 97 and B is equal to 56. So whenever you have some problems like this involving square root in the denominator, use this method to get rid of the square root in the denominator and then equate, compare the like terms and find out the constants A and B. That's it.